So in this particular problem, we need to determine the value of 10 raised to the power of 2x in terms of y, given log of y to the base of 10 equals to x. So let us begin. So we have log of y to the base of 10, and that's equals to x. Now if we use the definition and convert this to exponents, then we will get y equals to the base 10 raised to the power of x. Fine. Now what we have to do, we need to find out 10 raised to the power of 2x. So let's change the position. So we have 10 raised to the power of x equals to y. Now what we'll do, we'll square both sides. On squaring both sides, on the left hand side we have x times 2. That's the law of indices. So we get 2x, 10 raised to the power of 2x on the left hand side, and this is equals to y squared. So this is the final result. So here what we have done, we have expressed 10 raised to the power of 2x in terms of y, and this is the final answer. Let's move on to the next problem. So we have to express 8 raised to the power of x in terms of y, and then find the value of 8 raised to the power of x. So let us begin. So here we are provided log of y to the base of 2, that's equals to x. So we use the definition that this will give us y equals to 2 raised to the power of x. Fine. So this is the same as 2 raised to the power of x equals to y. Now what do we have to do? We have to determine the value of 8 raised to the power of x. So let's begin from 8 raised to the power of x. So 8, which is 2 multiplied to itself 3 times. So that means we can write 8 as 2 cubed, means the same. Now if we use the law of indices, then 2 raised to the power of 3 whole raised to the power of x. So that's simply 2 raised to the power of 3x. Or we can rewrite it as 2 raised to the power of x whole raised to the power of 3. Now 2 raised to the power of x, we have already obtained that value is equals to y. So that means we can finally say that if we substitute this value with y, so we can say thus 8 raised to the power of x, so that simply equals to y cubed. So this is the final answer. Let's move on to the next problem. Problem number 3. So here we have to determine the value of 10 raised to the power of 2a minus 1, and the answer should be expressed in terms of x, given log of x to the base of 10, that's equals to a. So we have log of x to the base 10, and this value is equals to a. We'll convert it to exponent, so that will give us x equals to 10 raised to the power of a. So let's box it. We are going to use this value in the y. Now we have this expression 10 raised to the power of 2a minus 1. So here we need to express it in terms of x. So let's break it down. So we have 10 raised to the power of 2a. So we have 2a minus 1. So that means this can be written as 10 raised to the power of negative 1. So you have separated the indices. Now 10 raised to the power of 2a. So this can be rewritten as 10 raised to the power of a whole raised to the power of 2. And we have 10 raised to the power of negative 1. So this is 1 over 10. Fine. Now 10 raised to the power of a, that we have already obtained, this value is x. So we have x whole raised to the power of 2 divided by 10. So therefore, this is the final result. You can say thus 10 raised to the power of 2a minus 1, this value is going to be x squared divided by 10, and this is expressed in terms of x. Let's move on to the next problem. So here we need to determine the value of 81 raised to the power of a minus 1, and the answer needs to be expressed in terms of x. So we are given log of x to the base of 3, and that's equals to a. So let's begin with the logarithm. So we have log of x to the base of 3, and this value is equals to a. So that means we have x equals to 3 raised to the power of a. So let's label this as equation number 1. Now starting with expression 81 raised to the power of a minus 1. So this can be rewritten as 81 raised to the power of a times 81 raised to the power of -1. Now 81, so that's simply 3 raised to the power of 4. So we have 3 raised to the power of 4, which is 81 whole raised to the power of a times 81 inverse, so that is 1 over 81. So this is equals to 3 raised to the power of 4 whole raised to the power of a. So this is simply 3 raised to the power of a whole raised to the power of 4. What we've done is we've just changed the order, because a raised to the power of b whole raised to the power of c. So that's simply multiplying the power. So that's b times c, and this can be also expressed as a raised to the power of c whole raised to the power of b, and that will mean exactly the same thing, divided by 81. We have already obtained 3 raised to the power of a, so that's x as per equation number 1. So we'll substitute this value here, and finally this is going to give us 81 whole raised to the power a minus 1, so that's equals to, so we have 3 raised to the power of a, so that will be simply x. So we have x raised to the power of 4 whole divided by 81. So this is the final answer. So we have to determine the value of 10 raised to the power of a minus 1. So let's begin with whatever we have provided. So we have log of x to the base of 10, that's equals to a. So when we use the definition, that will be simply x equals to 10 raised to the power of a. Now we have 10 raised to the power of a minus 1. So this will be simply 10 raised to the power of a times 10 raised to the power of -1. So 10 raised to the power of a, so that's x. So we have x divided by 10 raised to the power of -1. So that's simply 1 over 10. So this is the final answer. Let's move on to the next problem. In this problem, we need to determine 72 raised to the power of x. And we have to express the final result in terms of y and z, given 2 values of log. So here it's going to be a little more involved than the previous problems. Let's begin with the logarithms first. So what we have, let's take the first logarithmic equation. So we have log of y to the base 3, that's equals to x. So that means y will be equals to 3 raised to the power of x. Let's label this as equation number 1. And from the second log, we have log of z to the base 2 equals to x. So here we have 2 raised to the power of x, that will be equals to z, and let's call it equation number 2. Now we have 72 raised to the power of x. Now 72 raised to the power of x, when we factorize it, the factors will be 8 times 9. So 8 times 9 is 72. There's a reason why I've taken this particular case. Now we have, this can be written as 8 raised to the power of x times 9 raised to the power of x. This is the law of indices. Now 8 is simply 2 cubed whole raised to the power of x, and 9 will be 3 squared whole raised to the power of x. So this is 2 raised to the power of 3x times 3 raised to the power of 2x. Or simply put, let me write it here, 72 raised to the power of x. So we can rewrite it as 2 raised to the power of x whole raised to the power of 3 times 3 raised to the power of x whole raised to the power of 2. This is done so that now we can use equation 1 and 2. So 2 raised to the power of x will be replaced with z, where z cubed times 3 raised to the power of x will be replaced with y. So this is y squared. So that means we have obtained the value of 72 raised to the power of x. So this value is z cubed times y squared. And the answer is in terms of y and z. So this is the final answer. Let's move on to the next problem. So we need to determine the value of 100 raised to the power of 2a minus 1. And the final answer should be in terms of x and y. So here we're given. So let's begin with those 2 logarithms. So we have log of x to the base of 5, and that's equals to a. So that means x will be equals to 5 raised to the power of a. This is equation number 1. And log of y to the base 2, and this is equals to a. So that y will be equals to 2 raised to the power of a. This is equation number 2. Let's do one thing. Let's multiply 1 and 2. So if we multiply 1 and 2, we have x times y. So that will be 5 raised to the power of I times 2 raised to the power of a. Fine. So this will be equals to 5 times 2 whole raised to the power of a. So 5 times 2, that's simply 10. So we have 10 raised to the power of a, and that's equals to x, y. Let's call that equation number 3. Now let's come to our original expression. So we have 100 raised to the power of 2a minus 1. So this can be written as 100 raised to the power of 2a multiplied to 100 raised to the power of negative 1. Now 100 is simply 10 squared whole raised to the power of 2a whole divided by, so we have 100 inverse, so that's simply 1 over 100. Now 10 squared over 2a, let me write it here, I'm running out of space, so this will be 10 raised to the power of 2 times 2a, so that's simply 4a divided by 100. Now 10 raised to the power of 4a is simply 10 raised to the power of a whole raised to the power of 4 divided by 100. This is done so that 10 raised to the power of a can be replaced with xy. So that means we have xy whole raised to the power of 4 divided by 100. So this is the final answer. So let's write it down. So we have 100 raised to the power of 2a minus 1. So the final answer will be x raised to the power of 4 times y raised to the power of 4 whole divided by 100, and this final answer is expressed in terms of x and y. Let's do one final problem. So in this problem, we need to obtain the value of log of 1728 to the base of 2 square root of 3. So let us begin by supposing that this particular log value, log of 1728 to the base of 2 times square root of 3, let this be equals to x. Now we will apply the definition. So we have 1728, so that's equals to 2 times square root of 3 whole raised to the power of x. Fine. Now 1728, so that's simply 12 cubed, which is equals to 2 times square root of 3. Now what we will do, let's get rid of this particular square root by squaring both sides. So we have 12 cubed whole raised to the power of 2. So we're squaring both sides, and this will be 2 times square root of 3 whole raised to the power of x and the whole raised to the power of 2. So this will be simply 3 times 2, that's 6, and this is equals to 2 square root of 3 whole raised to the power of 2 whole raised to the power of x. So 2 square root of 3 whole square, so that simply equals to 12. So we have 12 raised to the power of 6 on the left hand side, and on the right hand side we have 12 whole raised to the power of x. Now you can see that the bases are same, so that means x will be equals to 6, and since x is equals to 6, and this is simply the value of the log, so this is equals to 6. So this is the final answer. Thank you.